All right, let's start from question number 2, where marginal cost A is given by 150 plus 3q, and marginal cost B is given by 9qb, and the common marginal benefit is given by 250 minus 4bq, which would be q1 plus q2. Remember, this is q1 plus q2. So the optimal production is given by marginal cost A is equal to marginal cost B equal to the common marginal benefit. Otherwise, if this is, for example, different from the marginal benefit, then we are going to produce less of it or more of it, because they are not equal, to reduce either the marginal benefit or the marginal cost. If these two are not equal, then we are going to reallocate quantity from A to B or from B to A. So these equalities are very important for the optimal point where we don't make any adjustments. So let's equalize these two to get some form of simultaneous equation. So if you equalize this, then I'm gonna solve for this. Is anyway our first equation, but we are gonna simplify it. So I'm gonna subtract 150 from both sides and then divide by 3. So this becomes qa 9qb minus 150 divided by 3. So 9 by 3 is 3qb minus 50. 150 divided by 3 is, so we have found that at the optimal point qa must be 3qb minus 50. Now from these two equations we can also get some kind of 9qb equal to 250 minus 4 times q1 plus q2, or qa plus qb, and this is our second equation, but we are gonna substitute this expression into qa, into this expression. So what happens? We have 9qb in here, 250 minus 4, but qa is nothing but 3qb minus 50 plus this qb plus qb. Okay, so instead of qa we have inserted 3qb minus 50. Okay, so this simplifies to 9qb equals to 250 minus, now 3qb plus qb is 4qb minus negative 4, negative 16 qb. Negative 4 minus 50 is plus 200. So let's simplify. Add 16 qb to both sides. This becomes 25 qb. Add 250 and 200. This becomes 450. Now divide both sides by 25. qb is equal to 450 divided by 25, which is equal to 18, I believe. That's a good news. We got a simple answer. Then this implies qa is equal to, remember, qa is 3qb minus 50. So 3 times 18 minus 50 gives you, I think, 4. This is 4. I think 3 times 18 is 54. Minus 50 is gonna be 4. So this is the optimal point, and the BQ is the sum total of these numbers. So you get 22, I believe, to be the total production, right? So that's one result. Now compare the social efficiency of 3 possible outcomes. One is that require both firms to reduce pollution by the same amount, which means you divide, this is part A. I think part B, 1, if you share 22 to both, 22 by divided by 2, which means 11. If you forces them to produce 11 units, then what happens to the situation? Well, this is inefficient because at 11 quantity, calculate the marginal cost. The marginal cost of A, so marginal cost of A would be 150 plus 3 times 11. This is something like 183, but for marginal cost B is gonna be 9 times 11, which is 99, which is less than, so we have to produce more of this actually. Firm B must produce more if we are gonna be efficient. So this is not really efficient. The second one is charge a common tax per unit of pollution. What require both firms to reduce pollution by the same amount, but allow pollution permit to be bought and sold. So in the second case, where the tax, what must be the tax? Remember, the tax must be where marginal benefit is equal to marginal cost. So what is the marginal benefit at basically 22 units total? The marginal benefit is gonna be 250 minus 4 times 22, which is 250 minus 88. 250 minus 88, it's gonna be 162, I guess. 162. So 160 is actually the per unit tax. In this case, that's where you have to put them. And then the third one is cap and trade. So for a cap and trade, remember, the market price will be set at 162 and the firms will trade, and this will bring us actually, they will trade until their marginal cost is equal, and that's gonna be equal to the marginal benefit. Therefore we have exactly the same result as in the case of the tax or the case of government driven optimal point. Okay, so